Hello, this is Bryant Myers and welcome to another episode of Debunking Flat Earth. I have got a really special episode for you today because I'm going to debunk 3 different videos all at once. And this is coming from a live stream that the Globebusters did. And basically they spent an hour of this live stream going through my first Himawari video over here. And it was really, I have to say, it was just a really pathetic attempt to debunking what I said. And it was really more of a venting session. But they did bring up a few points, mainly just parroting Paul on the plane in his video, which brings me to the other video we're going to debunk. And then just for fun, Phuket Word, he did also a Himawari debunking video. And gosh, his video is 16 minutes long and it was pretty much only 3 points. There wasn't a whole lot there. But I do want to address his 3 main points that he brought up. And I really scoured the internet. I'm trying to find every single rebuttal to Himawari, and I can't find anything that I can't debunk here. So I want to do my best with this and the first video to just have a comprehensive debunking of every single objection that flat earthers raised to Himawari. Because Himawari 8 is a flat earth killer. And of course they have to raise objections. They have to scramble and find an excuse. And I'm going to shoot them all down. So we're going to mainly focus on Paul on the plane because Globebusters and Dave or Dearth, they're clearly just parroting Paul on the plane. They don't have anything really. Well, there was one thing that Eero brought up on the Globebusters live stream, so we'll address that. They only went through 9 minutes of my video. They didn't go through the last 22 minutes. And I realized that when they're going through a lot of these points is that the later part of my video debunked what they were saying. So just want to set the stage with that. So let me just play the first part of the Paul on the plane here, and we're going to go through his whole video. I'm going to annihilate his video.
Today we're going to focus on the Himawari geostationary satellite, which we're told is something like a mind-boggling 22,000 miles away from the Earth, sending us a real picture every 10 minutes, and the weather data seems to be, pretty current. Well, unfortunately for the ballers, we're going to debunk that completely here, simply in the next 5 minutes, and show you how they fake it all.
And I am going to debunk your debunk, but yes, indeed, it is amazing that we can get these 11K by 11K images of the Earth in 16 different spectral frequencies that can be used to create true color images of the Earth from space, as well as different composites that meteorology and weather forecasting centers will use for very practical purposes of forecasting the weather. So I went through a lot of this in my first video, but I just kind of want to go through this scanning again because, Jaren and they brought this up. And, in the first debate with all those guys, the stitch lines but the thing is for these images to be high resolution, and I found a really good website at vastphotos.com, and they're a company that will make incredibly high resolution. And the way they do it is they're professional photographers and they're very good at what they do. But they will take a bunch of individual images at high resolution. And then they stitch all these together to create this amazing high resolution image. And I'll put a link below this so you can kind of look at some of their images. But this is the reason why the Himawari will do the scan. Because, and why it takes 10 minutes. They're getting high resolution images just like this company. And they're stitching them together to get even a higher resolution. So that takes 10 minutes. And Jaren even brought up that my video was only 2 minutes here. But it's like, Jaren, I cut out the middle part of it for time. He wasn't even paying attention. That it went from here then to down here. Oh, those guys. And they just kept going on about how it's not always 10 minutes, it's sometimes a delay. Well, listen, right on their website, they'll tell you that twice a day at 0240 and 1440 UTC time is their housekeeping. So we get 142 images a day, so there's an extra, 10-minute delay or 20 minutes total in these 2 times every day. So yes, a couple times a day there's a little bit of housekeeping, but they're not trying to hide that. And it's worth noting that the true color is created from the grayscale plus one of the infrareds is used to make the green more vibrant. So it's an amazing technology how they can convert this grayscale images into these vibrant colors. And I have a whole paper here. If you're interested, you can come to my site, dfe.net, if you're interested in how these images are made. Okay, so now I want to play the next clip here because we're gonna systematically demolish Paul on the plane here. So here's the next little bit.
Did you know the Himawari ironically means sunflower? So yeah, there's proof of the heliocentric sun worshippers model right there.
Boy, the flat earthers just always have to get in a 666 or a sun worshippers, just all these references that they just don't know what they're talking about. It's actually kind of offensive to the Japanese culture because in their culture, Hanakatoba is this symbolism of the flower, this beautiful meanings behind the flowers after they bloom every spring. And the sunflower does have some deep meanings, and it's kind of a revered flower in Japan. So a couple of things it means is radiance and respect. But it also has a deeper meaning lately with Fukushima, because the sunflower itself has very unusual properties in that it's able to extract very toxic substances from the soil. So here you can see an image over here of a sunflower that's kind of died, but they're able to extract these harmful chemicals and transmute them. And so the Himawari, which again means sunflower, has also come to mean a symbol of hope and recovery for Japan. Nothing to do with the heliocentric sun worshipping model. It's just ridiculous these guys say this stuff. So now let's get into the fundamental error on Paul on the plane's video.
Let's cut right to the smoking gun to start. Here is the website anyone can go to and see this all for themselves. On a side note, the Himawari is operated by the Japanese Meteorological Space Agency and brought to us by the NOAA, the National Oceanic and Atmospheric Administration's GOES geostationary satellite server.
No, Paul. No, it's not brought to you by the NOAA. The Japanese Meteorological Agency is its own separate thing. And this is the real fundamental problem that Paul is trying to link the Himawari images to the NOAA. And of course, like all flat earthers, they like to connect everything to NASA. All the conspiracies seem to connect to NASA. And I find it kind of humorous that, again, even in this comment section, he's like, look, everybody, go to this link here. And you can see, and I actually went to the link myself, and you can see it down here. But even people in the comments are telling him, it's like you didn't even do your own research, Paul. You're sharing a link, and obviously you didn't even read it. I mean, the link itself says these images are updated every hour from data provided by the Japan Meteorological Agency and brought to you by the National Oceanic and Atmospheric Administration. So what that means is that the FTP that we're going to look at here in a second on the NOAA server is actually just a backup, or they're real images of the Himawari, but it's just like a backup file. That's all it is. There's no CGI, there's no anything. They're the actual images from the Himawari, and they're just backed up on the NOAA server. Okay, so now let's go through the next section. We're going to actually look at some of these files, and we're going to see what Paul's talking about.
When you're at the FTP site, click here for the site description. So when you do, a text file comes up, and you can see right here, they tell you that all of the images in the archive use the underlying colored land images from the NASA Blue Marble dataset. Yep. So the Himawari is actually totally debunked right there. These aren't real pictures coming from a satellite in a geostationary orbit above the Earth getting snapped every 10 minutes and being beamed down for us to all ooh and ah over. They take the Blue Marble data set, which I'm sure you remember. They admitted years ago was a flat strip data pieced together by an artist named Rob Simon in Photoshop because it had to be, right?
No, Paul, none of that is correct. And again, as I just said, you're trying to link the Himawari or the Japanese Meteorological Agency to the NOAA, and I just showed that there's no link. So you're just taking this all the way, and you're just making stuff up here saying that, okay, now because you think that the Himawari is brought to you by the NOAA, where it's not, it's its own agency, that somehow this file, which is there, I mean, I've looked at the file, we can bring it up, and you can open up the site description.txt, and you can read it, yeah. So, but again, this base map of the Blue Marble data set is used for the GOES, and some of the nighttime images, but that's only because they need like a base map, and the Himawari has its own base map system that it uses. There's no Blue Marble data set at all in those images, so it's just based on a faulty premise that somehow the Japanese Meteorological Agency is connected to the NOAA, and it's not. So just debunked. I mean, this is just provably wrong. Okay, so this isn't the main purpose of this video, but I just get so sick and tired of hearing flat earthers talk about the blue marble data set. And this in and of itself, now this was back in like 2001 and 2002, but it's such an impressive process how they went about making this. And for flat earthers to use this as like a case study for, you know, our Earth being all CGI, they don't understand it at all. And I want to play a little video clip from Blue Earth Thing, and it's a YouTube channel that I'm going to put his link below. He needs a little more love because he's got some good videos. But I just want to play a little snippet of him explaining how the blue marble data set was collected.
To make this image, a satellite known as Terra carried the Moderate Resolution Imaging Spectroradiometer, or MODIS, and would take pictures of the surface. Then these images were stitched together later. The surface images were collected from June to September 2001 and were composited every 8 days to avoid clouds blocking the sensor. These images are available to the public, but before you download, realize these images are absolutely massive. They can contain up to 21,000 pixels across, not as a whole, across.
Okay, just a nice little overview. And so again, these satellites, they're taking super high resolution images. And I've got a couple here, and I'm going to put a link below my video where you can download these. They are absolutely massive. And if I zoom in here on Florida, where I'm at, I mean, just absolutely breathtaking images. And, you know, for flat earthers to just cry CGI, they don't understand that the blue marble data set came from real images taken over 4 painstaking months, as it was just explained from Blue Earth Thing. So what the blue marble data set, which was featured in the first edition of the iPhone, which it's kind of became a household icon. And the first part of creating a flat map of all these images was done by Reto Stockley. And then from his hard work, the next phase was done by Robert Simmons, the guy that, you know, we've all seen flat earthers quote as the one that photoshopped the Earth, et cetera, et cetera. No, what Robert Simmons did was that he took these painstakingly processed images, is that he then wrapped them around, yes, in Photoshop around a 3D ball. And he used a lot of high-tech procedures to do that, but he was taking those actual images and doing this. And even though there were some enhancements done, they came from raw data of the Earth, from a satellite. This is not CGI, flat earthers. You guys don't know what you're talking about. Okay, so now we're going to get into the next 2 parts, which is how, according to Paul on the plane, these images are created, which of course is absolutely false. So the first phase 1 here of Paul's approach is the weather over the ocean. So let's hear what he has to say about how weather is simulated or created over the oceans.
Then to just briefly show you how they generate a picture every 10 minutes with what appears to be accurate in current weather. This is basically what they do. Now, don't take my word for it, as I always say. Go check it out for yourself. Number 1, they have already created and stored transparent images of the weather over the oceans using climate simulation software, which they openly admit right here that they've done climate simulations up to the year 2095. But it's actually the year 2100 on this FTP server folder, and here's one of the images. And following some of the other images that you can find where the land masses are transparent, and they use all this simulation software to come up with the weather over the oceans. You know, since our weather data comes from our ground-based Doppler radar, and it's impossible to use ground-based systems to cover the entire vast oceans, so that's where the weather over the oceans comes from, their software simulations.
Okay, so at least he was correct in saying that Doppler can't cover the oceans. But there is no way that you can use any type of simulation to create cloud cover. And you can't even do Doppler, as we'll see in a minute. And this is a point that the Globebusters did bring up something new that Eero talked about, which we'll get to in a minute. But clouds need to be imaged directly. You need to take a picture of a cloud. You can't simulate it because cloud cover is way too complex. There's just no way, because not only do you got to deal with all the variables on Earth with cloud cover, you also have to deal with the sun, the chaotic behavior of the sun, and different solar flares and all kinds of things that can create all these different variations. But yes, they have simulation software, as we'll see, it's pretty good, but it'll never give you accurate cloud cover, never. So that's just patently false, and I'm going to show you proof of that here in a minute. So when we go into this, this folder here, you just click on the view, as you can see here, and for some reason, and I spent a good hour going through all these folders just to see what was there. And it turns out all these folders are just different types of kind of composite images where they take different, spectral bands, and they create, some of them are forecasting, sea surface temperature, coral bleaching zones, and they'll use different, spectra from these 16 wavelengths to create different types of images, right? And so I don't know why, and I circled it down here, I don't know why Paul and the plane just seemed to gravitate to the GP85, but if you go in there, you can see, well, I'm not going to do it, but you can see some of the images that he was bringing up. And again, these are just annual temperature forecasts. And as I mentioned in my last video, like Farmers' Almanacs, temperatures can be predicted a little, not exactly, but they can be predicted more easily, certainly, than cloud cover. And interesting, too, he talks about like they're just somehow singling out the sea. Well, I found there's temperature maps for the land, too. So it's not like they just have these ones for the oceans because Doppler can't cover the oceans, which is kind of his reasoning here. And again, go through all these folders. There's tons of other types of data in here. It's not like there's just this one thing. Okay, so now over the land, let's hear what Paul has to say how they fake space over the land.
Number 2, now for the weather over the land, the NOAA has supercomputers that take data coming in from all over the world, Doppler radar feeds, and crunch it all together and combine it with the weather simulation data over the oceans, so they come up with a complete composite weather quote-unquote map, which is then wrapped around a ball in their 3D modeling software programs, just like we've shown countless times in our previous episodes with the Earth and the planets, etc.
So first of all, Paul, you can't create clouds from Doppler radar. I talked about this in my last video. What you can get is like velocity fields, you can get like wind speeds and kind of droplet, like the density of the water. You can kind of get an overall, picture of the precipitation within these clouds, but nothing to do with detailed cloud cover. And like in some days you can go out in the sky, look up and see clouds, or you go to the local weather station that doesn't show anything on their Doppler. So Doppler cannot give you cloud cover. It just can't. The only way to get cloud cover is actual images of the clouds. So that's debunked here. Now I do want to get into just kind of mentioning weather balloons. And this is, now we got to, remember I said I was going to debunk Phuket word as well. So let's hear what Phuket has to say about weather balloons.
Well, something we can consider as a possibility are geostationary balloon satellites. Now, you can easily just look this up on Wikipedia, and here it says that geostationary balloon satellites are proposed atmosphere analogs to satellites.
Okay, so again, the problem with flat earth is they make a lot of these claims and have no evidence. So where's your evidence, Nick? I mean, you're saying that it's weather balloons, but when I look up all the different weather balloon stations, it's nowhere near to cover the whole Earth. And then there's the other problem is that, the GOES and the Himawari are geostationary satellites. They're following around. They're very, very stable. These weather balloons, even though they do have ways to adjust their elevation based on wind patterns to get the most ideal positioning, they still get blown around. And then you got the big problem of if you got, you would have to have millions and millions and millions of them across there. I don't even know how many. It's just a ridiculous number. And there's no supercomputer that can probably process all that data in 10 minutes. I mean, if they could somehow figure it out. And again, why would they do that anyway when satellites are so much cheaper, more efficient, and they just work better? So again, you're denying satellites. I get that, but the reason that they don't use weather balloons is because satellites just work a lot better for this purpose. And a lot of these balloons aren't really doing much imaging anyway. They're collecting things like temperature and pressure and humidity, and I don't know all the different variables, but they have a lot of variables that they collect, and then they get fed back into the weather systems for local forecasting usually. But there's no way that all these balloons are communicating with each other to create these images, Nick. I mean, that's just ridiculous. And if you're going to make a claim like that, where's your evidence? I looked online. I couldn't find anything even remotely suggestive that weather balloons give us these accurate images of the Earth every 10 minutes. Nothing. Okay, so now I want to play a little clip from Iru, who had some stern words for me at Globebusters. Okay, Iru, let's hear what you got.
So I want to tell Brian, this is a GOES 5 model cloud at 5 kilometers resolution, downloaded directly from NASA. And they provide all these maps, and they tell you right away. In fact, I can make a citation directly from a NASA employee.
Giant streams of air going across the oceans. You can see ice coming and going and snow coming and going over the land. And you can see the greenness changing. This is all a simulation, but a realistic one. It's a little toy world. And that's what we use to try and understand the Earth system. That's how we try and make sense of it all. So is this useful? Yeah, you bet.
Okay, Iru, I want you to listen to me now because I'm going to debunk the heck out of what you just said. So there's two reasons why what you said three reasons why it doesn't work. The first reason is if you actually go to the site and look at these maps, and by the way, this simulation that you were showing on your screen was at the time, it took a long time to create that. They used a higher resolution to create that image. And even with their best simulation, the one you were showing, if you look at the actual GOES satellite versus the simulation did a good job. But again, it took, I don't know exactly how long it took for this simulation, but it was extra long because they wanted to make it like a showcase. But it was definitely a long time. But even with it, look at the difference. There are definite differences. And I spent some time going through this. And the actual real images, there's just so much more structure and subtlety to the real clouds versus the simulated one, even the best simulations. Well, and this is only 90 hours in, Iru, to the simulation, and you're already seeing differences that are very noticeable. Because weather in chaos theory, you really can't, there are actual limits to weather prediction. So that's the first thing, is that these aren't even the same anyway. And we know from truth observations from Himawari that we can look up and we can get the same, we can see the same image from the ground as we get from Himawari. And now with ISS live feeds, we can also confirm our clouds on the ISS. So we have ways to see precisely with our cameras, and we can match those precise cloud images with the ISS and with Himawari, and they are not the same as simulations. Simulations can never give you accurate cloud cover. You guys just don't know what you're talking about. Absolutely don't know what you're talking about. And good luck trying to respond to this. I really await your response, Iru, and see what you have to say about this. Okay, Iru, but it gets worse. It's not even, I'm not even done yet. And this is admittingly, now this is an older one, but they were taking at least 6 hours to create each one of these simulations. And I think this one even took longer because it was a special case. But let's go to more of the more recent supercomputers. But if you go to the most accurate, up-to-date forecasting that they have in these supercomputers that can perform quadrillions of operations every second, and calculations every second, it still takes them a few hours to complete a run. Okay, and this is with the best of the best computers that we have. So every 10 minutes, no, they can't do it. I mean, you guys just need to, before you start talking and saying stuff, you should really research it. And, but it gets even worse, and I want you to hear this directly. So I want to play this little clip because it's going to give you a better idea how these simulations really work.
NASA satellites orbiting the Earth relay immense amounts of data back to scientists on the ground, who can then enter that data into computer model simulations.
So the NASA scientists will look at the observational data and make theoretical projections of what a model might look like, and they will build a numerical model based on the data and then run that on our computers and then compare that to reality.
Okay, Iru, now did you see the first part of that? They actually use live satellite feeds to feed data into these supercomputers. So they're not just like setting a program and modeling it into the future, they're getting constant input, meaning there's a feedback loop where they're getting real-time data coming in. So a lot of these images you're seeing are based on simulations from satellite data coming in and updating the whole system. Meaning these simulations depend on satellites, guys. It just debunks your whole argument. So you really need to look into what you're talking about before you start speaking. Now, I've been through 2 hurricanes in the past since 2017 with Irma and Ian since I've been here in Florida. And I have followed these spaghetti models and their predictions. And I'm telling you guys, you can't use weather simulations to give us accurate cloud cover because in both situations, especially with Irma, at the very last minute, the spaghetti models were wrong. It went like inland. And the same thing with Ian. It was right on track for us here in Sarasota area, Tampa, but it went south. I mean, at the last minute. And so all of the best supercomputers in the world were not able to predict the actual path, which is over here. And again, I was following this on the GOES satellite. And same thing with Irma. I mean, they had all these predictions, but the actual path it took was much different than they thought. They first thought it was going to go over here, then it was going to go, do something different. It was going to be cataclysmic in Naples, but it wasn't. I mean, it was bad, don't get me wrong, but it could have been a lot worse. So I have direct experience firsthand at how inaccurate weather predictions can be even the same day. So don't tell me that you think supercomputers can give us cloud cover images that we can verify with our cameras in ISS and Himawari or GOES. You guys are just so full of BS. You don't know what the hell you're talking about. I don't want to get into chaos theory because this video will go way too long. But it's really fascinating to me looking at like Ed Lorenz, who was one of the fathers of modern day chaos theory. And he was a mathematician and meteorologist. And he found with his weather simulations when he accidentally rounded, even 7 decimal places or whatever he did in his calculator, those small little errors compounded because the weather is very chaotic. It's very sensitive to initial conditions, where the planets in their orbits are very stable. They're not sensitive to initial conditions. And there's something called the Lyapunov exponent that kind of gives you a measure, like a horizon of predictability. The inverse of it's like a horizon of predictability. So we can predict the motions of the planets for, I mean, hundreds of thousands of years, even in the millions of years in some cases. But the weather, we can't go more than 15 days because one is sensitive to initial conditions and the other isn't. So this is what makes weather so difficult, because there's so many variables from the sun and the earth and the oceans and the land and the atmosphere. All these things, just small little changes can create, that's why he called it the butterfly effect, right? A small little change can cause a major effect, which was, of course, the title of his first paper, Does the Flap of a Butterfly's Wings in Brazil Set Off a Tornado in Texas? So there are, if you go to weather.us model charts, you can see some of these different modeling systems, which is where some of these spaghetti charts come from. And again, you're not going to get cloud cover from this modeling accurately. I mean, you get forecasts and you can get sort of predictions, but you're never going to get accurate cloud cover data. So putting it all together now. So first Paul said, over the oceans, because there's no Doppler, which there's not, they have to use these weather simulations. And I showed, of course, that that's not going to work. And then over the land, they can use Doppler. And of course, that's not going to work either because Doppler won't give you cloud cover. But let's just see what Paul has to say, because he's just got a really weird way of putting this all together.
Then what we get are composite images like this that are created in the 3D modeling software. The current Doppler weather data over land and the simulated weather over the oceans, and it looks like this. So this particular image is on the FTP server and is date and time stamped with October 11th, 2017 at 11:05 a.m. I just chose one randomly. Notice the image shows you the weather for the whole ball and not just part of the ball that is lit by the sun at this particular time. No Terminator line or anything like that. Right?
Okay, so again, I don't know where his reasoning is coming from, because I mentioned this in my last video because Dave or Dearth also brought this image up, and he's like, this is the image where they take the ocean data and they take the land data and they wrap it around the ball, and somehow this creates this accurate weather and cloud cover that we can all visually see. I mean, this is just an air mass imagery composite, and actually the Himawari and the GOES create many different composites. So I don't know why Paul decides to go with you can see it right here, the RGB air mass folder, because there's a whole bunch. And again, I really did my research on this video. I went through, there's actually a paper written here, and you can download this on my site if you like. And it goes through all these different types of composites. But the air mass imagery is just one of many. Again, I have no idea why he singled that one out. Like 20 different composites here in this paper. And they all have different purposes, and I won't get into them. I'll just refer you to the paper here. But I do want to look at the terminator line thing, which Jaron kept bringing it up, and Dirth brought it up. And it's clear they didn't watch my video because I explained it in the second half. But they admitted they only watched the first 9 minutes of my video, my last one, right? So they didn't even talk. They didn't even see what I talked about the terminator line. But let's see what Paul has to say here.
Now, also notice the final image has a terminator line added in to try and make it look like a real picture from space, which drives a nail in the coffin of the Himawari because the weather data shows it over the whole ball completely. But they have to add a terminator line to show the Earth only partially lit by the sun based on the time of day that the photo is allegedly taken. So if this is a real picture, how did they know where to put the clouds and weather on the part of the globe with no sunlight? It's completely dark there.
Okay, now this is just a facepalm moment here. Even with Dirth, don't you guys realize that we can image in the dark with infrared cameras? Haven't you guys ever heard of an infrared camera? And even though I mentioned in my first video, and which you clearly didn't watch, that the Himawari has 16 different frequency bands, 13 of them are infrared, so that's what's lighting up the clouds. The Earth itself is lighting the clouds up, but in the infrared bands. I mean, this is just, and it's not even that difficult to understand. If you've seen an infrared camera before and you understand a little bit about how the Earth re-radiates a lower frequency as the energy gets absorbed from the sun. It's a black body radiation curve, so it's obviously it's much cooler than the sun is, so it's not going to be emitting the higher frequencies that the sun does. It emits a lower infrared bands. And I got a little paper here I looked at. I'll put a link below this video if you're interested on how cloud detection from thermal infrared images using a segmentation technique. So again, there's some good research on how cloud imaging can come about from infrared cameras, which of course Himawari and the GOES 1617 has. Okay, so the point is with this terminator line is they're not painting the terminator line on. It's not Photoshop. Those images from Himawari, that's the real terminator line. They have infrared cameras to help to light it up when it's dark. These are real images, guys. Okay, I want to go back to Phuket here because he does bring up a few things that Paul doesn't bring up and the Globebusters didn't bring up.
City lights. We see no city.
Okay, so Phuket's basically bringing up we can't see city lights at night from Himawari, but you got to realize that out there the sun is always present. So the Himawari cameras are adjusted to get really good images of the Earth. Okay, they're not going to pick up little tiny lights at 22,000 miles up. Now, you will see at times, in certain conditions, maybe eclipses that might happen. Or with lightning storms, there's some really good images. If you Google this online, you'll see like during lightning storms, the Himawari will pick those up. But typically the city lights just aren't bright enough based on how far the Himawari is back and how much light is coming in from the sun. Just washes it out.
This Earth image that we have supposedly suspended in space, which really should be a glorious background of luminaries and stars and all kinds of things. But of course, we do not see anything of the sort.
So to address what Phuket has to say about the stars and the moon and other luminaries around the Earth, it's because they're scanning very close to the Earth. Because if you scan this whole like rectangular square area, you'll waste about 21%. So Himawari and the GOES are designed to be very efficient to scan the whole Earth as quickly as possible. So they're not scanning out here for stars and the moon, but it just so happens that there are times where the stars will come in on the fringes here of the scan. So here you can see Betelgeuse, and even as bright and as big as a star is, because of the sun, it's just not going to be all that apparent, but it's there. And same thing with the moon. When the moon is really close to the edge, you can see this really great image here. It does appear. So again, even though it's got a very limited range in the scanning schedules, these stars and the moon does appear from time to time. Okay, so coming down the home stretch here, I just wanted to be very thorough and cover every one of these points. Now, this is just a really good added piece of evidence, or very convincing evidence, that we can see that these images are really coming from space. So now this photograph here is of the Himawari 8 and 9 by Wolfie 6020. Very beautiful image. In these satellites, you can actually track the GOES 16, 17 and the Himawari. But you could even do better than that. Not only can you track them, but you can actually pull the images. And this is kind of like a black swan for the whole attempt for flat earthers to try to debunk Himawari, is that if you're really motivated to find the truth, there are tutorials online that can teach you how to build antennas to actually pull these images directly from space. And I want to play a little clip here from the Thought Emporium because this is such a great piece of evidence.
Centimeter long piece of PVC and some zip ties to hold it in place, and our signal was way better. Now all we need is some software to make this work, and we'll be capturing images in no time. We use the GOES Tools programs made by Peter N., which is in turn based off of work of Lucas Teskey and the Open Satellite Project crew. There's a lot that has to be done to turn the radio noise we receive into actual info, and Lucas has an awesome set of blog posts where he goes through all of the maths required to make this work, which I've linked to in the description. Instantly, data started flowing in as soon as we set things running. The sun had already set at this point, but within half an hour, sure enough, a beautiful color image came through where the west coast was still clearly visible. And with that, the story arc was finally complete. The thing I've been talking about for years at this point has finally been done.
So not only are you seeing the satellite, but you're downloading the data from where your antenna is pointed. I mean, what do flat earthers need to be convinced? This is just undeniable evidence that these images are real. Okay, so I hope you really enjoyed this video. I've just gone through and just totally annihilated pretty much every single objection that I've seen of flat earthers to the Himawari. I mean, what else do you guys got? I mean, the Himawari 8 and the GOES 16, 17 are just annihilating flat Earth every 10 to 15 minutes. And yes, sometimes 20 minutes. Anyway, I hope everybody enjoyed this video. Please do leave some comments and like this video. And do subscribe to my channel. I do have many more coming. Again, I hope you enjoyed it, and I hope you have a great night. Bye-bye now.